The monotone convergence theorem has two conditions to determine sequence convergence. The first condition is that a sequence is monotone for all n greater than or equal to n naught if it is increasing for all n greater than or equal to n naught. The second condition is nearly the same, but concerns when the sequence is decreasing. A sequence is monotone if it is decreasing for all n greater than or equal to n naught. To use the monotone convergence theorem, a sequence must be monotone. In other words, there is some number n past which the sequence is always increasing or always decreasing. Second, the sequence must be bounded. If both conditions are true, the sequence converges. Otherwise, another approach must be used to test convergence. For example, take the sequence n to the fourth over n factorial. Use the monotone convergence theorem to show that the sequence converges and find its limit. First, compute the first few terms of the sequence starting with n equals 1. We'll compute the first 7 terms. This gives us the set containing the values 1, 8, 27 halves, 32 thirds, 125 over 24, 9 fifths, and 343 over 720. This is also shown in the graph to the right by plotting each point and drawing a curve to connect them. At first, this sequence increases, but after n greater than 3, it decreases. Therefore, since n to the fourth over n factorial is greater than 0 for all positive integers n, the sequence is bounded below by 0. In other words, this sequence can never be negative. This function is monotonically decreasing and bounded below. Therefore, it converges. Next, we want to find its limit. We can rewrite a sub n plus 1 in terms of a sub n. This gives us n plus 1 to the fourth over n plus 1 factorial. Factor out n plus 1 over n plus 1 to get n plus 1 cubed over n factorial. Second, multiply by a sub n and its reciprocal to get n plus 1 cubed over n to the fourth times a sub n. Next, take the limit of both sides as n goes to infinity. The limit L equals 0 times L, which equals 0. Therefore, the limit as n approaches infinity of n to the fourth over n factorial is 0.